All right, hi everybody. This is our Unit 2 presentation 7, and we'll be talking about energy. All right, this will be our last presentation before we start our car project. So here we go. So first thing is, what is energy? So energy, right, is the big key word is this. It's the object's ability to do work, okay? And we talked about work as last week, right? Work equals a force times distance, right? How can we take an object, create a force, and move it somewhere else? And that's what energy is. Energy allows for us, or allows objects to do work, okay? And it creates a change in an object, right? Whether that's changing directions, whether that's changing acceleration, but that's what energy allows us to do, okay? And again, like I just said, it comes in different forms, and we'll talk about 7 different ones to be exact, all right? We'll be measuring joules and also, and I should have wrote this down, and in calories, right? Yeah, you probably heard of the word calories before because it's something that you think about when you eat, but that is an energy form, right? Or energy, what we measure in energy. And the 2 categories of energy that we'll be talking about is kinetic and potential energy, all right? So all these different forms that we're going to talk about can fit into one of these specific categories of energy, all right? And I have a picture right here to just kind of show you, because I'm sure none of you guys have really heard what a joule is and stuff. I know that if I said, hey, something went 1 meter, you probably know what 1 meter looks like. But what does 1 joule of energy kind of look like? It's basically if I took a 1 kilogram object and if I pushed it with 1 newton, 1 meter, it would give me, that would take 1 joule of energy to go that to be able to do that kind of work. So 1 joule is not a lot of energy, right? Because it doesn't take me that much effort to be able to push, right, a 1 kilogram, which is about 2.2 pounds, object with 1 newton of force, 1 meter. Okay, so that's the unit of measurement that we'll be using throughout. All right, so let's talk about what is. Let me clear all this stuff out. What's the difference between kinetic and potential energy? All right, and I'll go over just some of the key points here. Is the biggest thing about kinetic energy is the object is in motion. All right, that's the difference. And potential is the object is, or the energy is stored in the object. All right, now that means that the object might not be moving. All right, usually it means that the object is not moving. It's being stored in there. And I wrote these key words here. It has the potential to do work, while kinetic is doing the actual work at that time. So in other words, the object is moving with some kind of force. All right, that's how we can do that. And there's 4 different, there's 7. I'm sorry, there's 7 different types or forms of energy that we'll be discussing, and these fit within each one. So in kinetic energy, there's 3 types we're talking about. There's one that's just the generic kinetic energy. All right, sometimes you'll hear people say mechanical energy in this sense, right? Electrical energy, and then what's called thermal. Some of people might call this heat energy. All right, we'll talk a little bit more about that in specifics. All right, the types or the forms of potential energy that we'll be talking about is called gravitational potential energy, so gravity, elastic potential energy, chemical energy, and nuclear energy. So these are the 4 potential energies that we'll be discussing. But the main thing I want you to understand about the difference between kinetic and potential is that kinetic is the object is moving, all right, it's doing. Potential is the object is getting ready to do something. Okay. All right, so let's go over each one specifically. Oops. Sorry, clear annotations. Okay, so first one is gravitational potential energy. And by the way it sounds, right, we're talking about how gravity is affected. Again, the key in this is it's stored energy, right? Because all potential energy is stored energy. And how you store it is its position, its height from the ground. So basically the idea is the higher the object is above, the more energy, more potential energy that object has the potential to do. So in other words, if you look at these two pictures, right, I've got a skateboarder on a half pipe right here, right? The higher the half pipe goes, so in other words, let's say that the skateboarder goes a little bit higher right here, that means that that person would have more energy, more potential energy than if, say, like the skateboarder was down here, right? Kind of makes sense. Same thing with a ball. If I'm dropping a ball, say, from this height versus dropping the ball from this height, right? I'm going to have more, right, potential energy here, and this one's going to have less potential energy here because this one has the ability to do more work, while this one has less ability to do work because there's less distance to be traveled. Okay, pretty simple idea. This is the one that we'll probably be using the most when it comes to potential energy, just because gravity's all around us. Okay. The next one, right, is elastic potential energy. So this one is the energy that's stored in elastic materials. So in other words, things that can be stretched or things that can be compressed. All right, so it's both. So it doesn't have to be just tension or compression. All right, but the idea is, and this is where kind of like our idea of forces now mingle with energy, right? Is the idea of that if you create more tension, you create more energy. If you create more compression, you create more energy. So these are the two things, right? If we want to do that. And some of the labs that we'll be discussing is talking about how do you create more energy, right? And this is just some of the things that you can do to be able to do that, right? So I have kind of pictures of all these kind of things. But the idea is it's pretty simple, right? Stretch it more, you get more potential energy, okay? So it has the, again, the key words are it's stored energy, so it has the ability to do work, but it's not quite doing the work yet. Like when I pull a rubber band, right, I'm not doing any work yet until I let go, and then it flings a guy, so it's storing all that energy. Okay. The next potential energy that we'll be going over is chemical energy. All right, and you use this every single day. I know you don't think of it as a form of chemical energy, but the food that you eat, right, is a chemical energy. There's chemicals inside of the food, and those foods give you energy, right? So like if you think about it, the days that you don't eat, you probably feel kind of down in the dumps, or like as you get closer to lunch, you probably haven't eaten, and therefore your energy level is probably pretty low. And so you probably need to get something to eat to do that. So there's that. So there's energy for you, and then there's energy for, right, the stuff that you use on a daily basis, which is the technology. So the computer right now that you're using, right, is stored in the batteries. Again, the key word is it's energy stored, right? And this time it's in what we call the molecules. So there's molecules inside of food, inside of a battery, right? So a battery and food really don't give like they don't do energy. What they do is they store the energy. It's up to you how you want to use that energy that you're going to do. Like in a computer, right? If I have the computer off and I'm not doing any work on the computer, like if I'm not playing a game or anything like that, there's no work to be had. But when I'm charging it, I'm storing all that energy, right? So think of it as a place that you're just kind of storing all that stuff into. That's what chemical energy is. Okay. Again, the object is not moving. It's about to do work. Right. Okay. So the last potential energy that I'll be discussing is nuclear energy. And so nuclear energy, again, it's stored. Right. That's the key word that I've been using. It's stored inside the nucleus of an atom. And hopefully you've learned a little bit about the atom, that there's protons and neutrons, and there's a lot of energy involved in that. And the way that those energy can be stored, right, in there, can be released through what's called fission and fusion. Right? Maybe you've heard of two of these words before, but basically what happens is in fusion, right, and I'm showing you the two pictures, a power plant, and this is our sun, right? This is where we get a lot of our energy from. Right, this is the power plant, right? And the idea of we get nuclear energy from both of these. This is probably the biggest source of potential energy besides gravitational that we get, because the sun's out every single day, right? And so a lot of your homes are probably also the energy comes from power plants that to get your electricity and all those kind of things. But this energy source comes from fission or fusion. And the way that happens is in fusion, the two nucleuses of the atom, they hit each other super hard and they combine to make one new atom, right? And when that happens, you get this enormous amount of energy, which is called nuclear energy, right? And same fission is the exact opposite. It's when two atoms split, right? And again, we can create a lot of energy from this. It's just really dangerous energy sometimes because we all know about nuclear power plants and so on. But basically, the sun is a nuclear power plant that's occurring. That's with this one, with the sun, fusion is taking place. Okay, so we can get nuclear energy this way through that. Now, moving forward, we're going to talk about now kinetic energy. All right, so now we're going from stored energy, so the ability to potentially do work, to now what happens what kind of energy do we get when the object starts to move? All right, and the first one is your generic kinetic energy, right? Even though it's in the category of kinetic energy, there's a specific one called kinetic energy, and that's the energy of a moving object, right? Anything that's moving, like as you can see from Homer Simpson moving, a car moving, that speed has a kinetic energy, right? And it comes from some kind of a potential energy. And we'll talk a little bit more about the transformation of energy later. But the idea is the more speed an object has, the more kinetic energy that object has. Right? It's a pretty simple idea, but it's basically the energy of any moving object. This is a pretty generic type of force. Right? So the next one is electrical engineering or electrical energy, and this is a big one because we use technology so much, so we're reliant on electrical energy a lot. All right, what would you do if you didn't have your iPhone, or if you didn't have a phone, I guess cell phone, or if you didn't have a computer like the one that you're probably watching this on right now, right? But electrical energy is, again, some of you guys are like, wait, how is that moving energy? Well, energy comes from the movement of electrical charges, right? So things that have electrical energy have what's called, or anything really has electrical charge. It's when they start to move, you create electrical energy, all right? This is how we get electricity. That's how we turn on a light bulb. That's how we turn on a computer, right? Now, this is a little different from chemical. I know that we learned that chemical is your battery, right? Electrical is what happens after you use the chemical energy. So a lot of times chemical energy and electrical energy will be together in a sense, because in order for you to have electrical energy, a lot of that power source comes from the potential energy of chemical energy. Okay? But in order for you to have more electrical energy, and I didn't really write this down, but if these move more, you get more energy. Okay? So it's all about the movement of what we call electrons. So when the electrons move really, really fast, you create more energy. All right? So that's another form. Again, we see this on a daily basis, right? Anything that turns on that creates electricity, you create electrical energy, right? And then our last one that we're going to be discussing is thermal energy. And a lot of people will call it heat energy, as you see right here. But basically energy that comes from heat. So anytime that you create any kind of something that changes temperature, you're creating a thermal energy. So boiling water, right? When you boil water, what's happening is the particles inside are moving very, very quickly. All right, so there's movement of tiny little particles. That's the reason why it's a kinetic energy. Remember, kinetic energy is the movement of objects. Okay, so there's little tiny particles inside of everything, and it's the movement of those tiny little particles, and the faster they move, the more thermal energy that you get. Okay, and rounding it out and going back to what we've been talking about with friction and forces and all that kind of stuff. So this is me rubbing my hands together. obviously you've done this a lot of times, right? When you're cold, you do this, and what do you notice? You get heat generated from that. So one thing that you're always going to get, right, in a lot of reactions or experiments that we do, friction is a very common form of thermal energy that you create. And we'll be discussing more about that because in the labs that you're going to be doing, you're going to have friction. So therefore, if you have friction, you have thermal energy that's being created. All right, now that we are finished talking about the different forms of energy, the big part of energy that we are going to go over is just the idea of energy transformation, that all our energy is always transforming from one type to another type of energy. All right, usually energy doesn't just stay, like if it's chemical, it doesn't always just stay as chemical, right? It always transforms into some other type of energy. And energy goes from one type to the next. And I'm going to just say this really, really quickly, but energy is what's called conserved. In other words, I can't create or destroy energy. It just turns into other types of energy. All right, so if I start off with, let's say, 50 joules of energy, that means that ultimately in the end, I'm going to have 50 joules of energy. It's just going to look differently. Those 50 joules are going to go to other types of energy sources. All right, so the idea is I have one that's a pretty, I think that a lot of you guys would recognize, is a roller coaster, right? And during a roller coaster, there's a lot of energy that's being transformed. And particularly it's gravitational potential energy and kinetic energy, right? And we'll talk a little bit more about where that thermal energy is going to. But the idea is roller coasters are used because of their height changes as they go along, right? There's a height of a loop and then there's the drop, and that's what makes a roller coaster really, really fun. So when a designer creates something, they think about where can I create my potential energy and where can I create the most kinetic energy to make it fun. So here's a picture of just a roller coaster going from the very, very top and dropping all the way to the very, very bottom. And so how does that energy transform? So if we're at the very, very top, right, so like usually the roller coaster is moving the slowest at this point, so there's not a lot of kinetic energy. And so this is where we have the greatest, right? And I'm going to put this for short, GPE. That stands for gravitational potential energy. I'm not going to write all that out. But this is where it's the greatest in this picture because it's at the highest point. Now, as the roller coaster falls down or goes down, that gravitational potential energy starts turning into kinetic energy, right? It starts to transform into kinetic. Why is it? Because now we're going from little bit of movement to a lot of movement. And when you get a lot of movement, we learn that kinetic energy is the energy of a moving object, right? And as the roller coaster keeps going down, where is the kinetic energy the greatest? At the bottom of the hill, because it's just now picked up so much acceleration. So at the very, very bottom, you're going to have the greatest kinetic energy, all right, of this entire roller coaster. And that's kind of how energy is transformed from your potential energy. Again, remember, potential energy is the ability to do work, but it's not quite doing that work yet. It's storing all that energy. And then once it's released into kinetic energy, which is happening because the roller coaster is moving. Now, where do we get thermal energy? Remember what I said thermal energy mostly comes from? Friction. In a roller coaster, you're always going to lose a little bit of that energy to friction. So all that potential energy, the gravitational potential energy, it doesn't all turn into kinetic energy. It turns into kinetic energy and thermal energy, right? Which is lost in friction. So that's what I'm talking about when we're talking about an energy transformation, is in each situation, is that. Let's look at another example that happens probably on a daily basis with you, which is the use of a laptop, right? When you're using a laptop, energy is being flowed, right? And it's not staying as just one type of energy. It's constantly flowing through. And so where does it all begin? All right, it all begins with some kind of a potential energy, right? This is my potential energy, and that's in my battery, right? So that energy source has to start from somewhere, and that's going to start from there. Now, where's that chemical energy go? Well, from the battery, what does it do? It turns on my laptop, and I'm able to type on my laptop because now there's electricity running through that, right? And when electricity is created, I'm creating those electrons and those electrical charges from moving, so I create electrical energy. All right. Now, during that time too, I'm also going to get some thermal energy. And if you've had a laptop in your lap before, you understand that, right? You all of a sudden start getting heat. The laptop starts getting warmer, right? So that's not really the heat that you feel. It's not electricity, right? The heat is because it's creating thermal energy. So that chemical energy turns into electrical energy, and then that electrical energy is now turning into thermal energy because the laptop gets hot, and eventually, right, I know that I have a picture here of it burning up. Obviously, most laptops don't do that, but you get the idea that you're getting heat, and that heat isn't really electrical energy, it's actually thermal energy. So there's three forms of energy that's being created or being transformed into just as simply using a laptop. Okay, so that's kind of like how I want you to look at the tracing of a heat flow. All right, so the last one that I'm going to go over and I want you to figure out is this, and we'll talk about this in class. I'm not going to give you the answer now, but what I want you to figure out is this. I want you to trace the flow of energy of a person, right, skateboarding up and then down a hill. So let's just imagine that the hill is like this, right? And the skateboarder wants to go up and then down that hill. I want you to start with the energy flow from the sun. All right? And then I want you to transfer all that energy all the way to whatever energy is going to be at the bottom here. Okay? So this is going to be a multi-step energy flow. All right? I know you're going to probably you might have a difficult time at the very beginning of this, but we'll go over this in class together on Monday. But I want you to try, starting with the sun, right? So think about all the different forms of energy that we've kind of talked about. Starting with the sun, how does that energy transform from the sun to the skateboard going up and down the hill? Okay? All right. Congratulations. You're done with these sets of notes.